In the real world, production applications should never store passwords in clear text. Instead, passwords should always be hashed and salted. Hashing is defined as putting a password through a hashing algorithm, be it bcrypt, SHA, etc., to turn plain text into an unintelligible series of numbers and letters. In contrast to encryption, hashing is a one-way mechanism. Once hashing has been done, it should be impossible to go from the output to the input. Salting is the act of adding a series of random characters to a password before going through the hashing function. Thus, the input is made up of the password plus the salt. Note that the salt should be unique for each password. Password salting helps developers increase password complexity without affecting user experience. Adding salt makes it very difficult for hackers to guess the original password using a rainbow table attack. In this extension, we'll be using the bcrypt algorithm that is based on the Blowfish cipher. It is designed to be slow and not to allow any shortcut, hence slowing down any attack. Alright, so let's get started and get a dependency installed before we begin. Let's head over to our IDE, and inside of our terminal, let's install the bcrypt package and its type definitions. We have these packages already installed, so we'll skip ahead, but if you're following along, go ahead and pause the video until everything finishes installing. Once it's done, before we dive into all the good stuff, let's first wrap up all of our upcoming work into a new module. Let's generate a new Nest module and call it IAM, short for Identity and Access Management, via Nest G module IAM. Inside of this module, let's generate two services. One that will act as an interface, let's call it Hashing Service, and another one representing its implementation, bcrypt service. We'll generate both services inside of the im/hashing directory as follows. Let's open up the newly generated hashing service file first and make a few adjustments. Let's start by making this class abstract, as we want it to act as an interface or hashing service abstraction. Next, let's define two abstract methods that will have to be provided by the concrete implementations. Hash takes data as an input argument and returns a hashed string, while compare also takes two arguments, data being the data to be encrypted, and encrypted being the data to be compared against. This method will return a promise to be either resolved or rejected with an error. With this in place, let's open up the other service we just created, bcrypt service, and make sure it implements our new hashing service. Our IDE should prompt us to auto-implement this interface, so let's go ahead and do it. Next, let's update the hash method and make use of the hash function from the bcrypt package we just installed. First, let's flag this method as async and then replace its context with the following code. Now onto the compare method. Similarly here, let's use the corresponding compare method from the bcrypt package as well. And that's it. Note that all of the code here can be found below the course video. Lastly, let's open up the IAM module file and let's change a few things in there. You may have noticed we're getting some errors at the moment here. This is because the hashing service is an abstract class and it can't be registered as a provider since it cannot be instantiated. To fix this up, let's replace the providers array with the following code. With what we just did here, now whenever the hashing service token is resolved, it will point to the bcrypt service. Hashing service will serve as an abstract interface, while bcrypt service is our concrete implementation of that service. What we've done here is really useful because if we ever decided to migrate to a different hashing algorithm, we could simply create a new service that implements the hashing service and update this provider to point to the new service instead of the bcrypt service class.